So my name is Jen Bayer. If you don't know me, I work for USGS and PNAP. And PNAP is delighted to bring to you today part 3 of a 5-week webinar series focused on pit tag data analysis related topics. I hope you've been able to join us for our previous 2 sessions, because this has been a very nicely scheduled series of things that a group of people put together intentionally. And Meg Detloff is not with us today, but she was instrumental in getting this all organized and going. If you missed the previous 2 sessions, you can find them at the PNAP YouTube channel, where you can find this session after, well, it'll be next week, and the subsequent ones. So let me jump into a couple of housekeeping things. I think everyone's pretty familiar with Teams, but you should especially know that it's really nice to have your camera off unless you're the speaker, just so you're not distracting, and also mute yourself, of course, unless you have a question. Kevin C is going to present, and then Brian Maschhoff, and so we'll have time after the presentation for Q&A for each speaker, and then at the end of the 90 minutes, we have 30-minute office hours. So stick around. If we run out of time during each speaker, you can come back for questions, but try to keep yourself muted other than those windows, just for distraction's sake. If PNAP staff have to mute you, you have to unmute yourself. Just know that. Our welcome slide. We are glad you are all here, and we're delighted to be here today too. All right. So I mentioned we have 2 speakers today. We have Kevin C. from Washington Department of Fish and Game and Brian Maschhoff from Salmonetics. They're both going to speak about applications related to ways you can clean and organize pit tag data. And they're both going to have a few slides, and they're also going to jump off to some real live web applications. So applications for real. And I think with that, also I did mention recording, sorry. I think we're ready to go, Kevin. I'm going to turn it over to you. Thank you so much for being here.
Thank you for having me. I really appreciate it. Let me see if I can share my screen now. There we go. Looking good for everybody else?
Yes, that looks great.
Excellent. Well, again, thank you so much for having me. Excited to be here. I'm a research scientist with Washington Department of Fish and Wildlife. Gonna have a chance to talk to you today about an R package I've been working on for a number of years, that the goal is to help wrangle and kind of prepare pit tag data for further analysis or visualization or other things like that, called PITcleanr. And so with that, we'll kind of jump in. Kind of brief overview. The plan today, we'll talk a little bit about a lot of the benefits, just touch briefly on those. I'm sure everyone here probably understands those. That's why you're interested in pit tag data. Also talk a little bit about some of the challenges that come with that data, and how PITcleanr might fit into that and could be useful. I'll talk a little bit about the purpose behind it. My big goal is to give a big overview of some of the functionality contained within that package. Kind of like a big buffet of, hey, you can pick and choose different things that may or may not speak to you for particular questions, particular analyses, and something that, can't go into a whole lot of detail during this talk about any particular function, but I'll try to at least give everyone an experience of these are all the possibilities out there, and then wrap up by talking about some of the resources we've developed for the package to help you go back and read on your own with some more deep dives. And I'm certainly happy to talk either at the end of the talk or during the office hours, or later in the future, anytime. All right, let's set the stage with pit tag data, make sure we're all on the same page, just so that the vocabulary I use makes sense. So this is what I typically conceive of as a pit tag site, an in-stream site. It's got 6 antennas. You can see those labeled there, configured into 2 different arrays, an upstream and a downstream array, right? And fish that are tagged and swim past there, give little pings. You get data for this individual tag code on this antenna at this date and time, which is fantastic. So pit tag data is full of information about individual fish. And we use that to look at their movement, to look at timing, estimate survival, right? It's a wealth of information, which is fantastic. What comes with that wealth of information is a ton of data, which can be a bit overwhelming, right? And so just as an example, right, looking through one of the example data sets I have in the PITcleanr package, found one juvenile fish pinged 681 times at a single site like this, just within 12 hours in the Lemhi River. That's 681 lines of data that you get for that one fish that says it's still sitting at that site for 12 hours. I don't know that I need all 681 lines of data, right? That's part of what makes this kind of data set overwhelming. Generates a ton of data. Just as another example, right, this is going to be the example data set we kind of play with a little bit, but this is just to give you a sense here. You can see we're pulling out 1,400 different tags from 50 different sites, and those tags generated 13,500 observations, right? And you pull that down from PTAGIS, and it looks something like this. You get a line for every little ping, full of information, like I said, but that's a lot of data and a lot of things to try to figure out, okay, what am I doing with that? How do I translate this into something that's useful for me, for whether it's I'm trying to visualize this, I'm trying to analyze this in some way. What can you do with all of this data? Clearly not, well, yeah, let's leave it at that. And this is just for a fairly small, small system, right? It's one little watershed. The origins of the PITcleanr package, we're dealing with systems like this, Snake River. You can see all of the different pit tag sites, little black dots there. I was working on some projects there, looking at a couple different species, trying to estimate their movement across this entire network, across many different years. We're talking tons and tons of data. And so trying to ingest data at that scale, how can we simplify it? And so PITcleanr started off as just trying to build tools for me, for my own personal analyses. And over the years, I started to realize that a lot of the wrangling of that data and transforming it into something that was useful, that step was what I was going through and doing any kind of pit tag data analysis, or at least a lot of them. And so pivoted and tried to make PITcleanr a little more generic and make the tools hopefully helpful for a lot of different kinds of analyses or a lot of different kinds of questions, or really for anybody who's dealing with pit tag data and wants to summarize that and kind of clean it up and so forth. So that's kind of the little overview of kind of the purpose behind it and why it's in existence. Then I wanted to get into a little bit about just, all right, what's contained in that package, right? The goal, as I mentioned, it's to make your life easier. It's to help wrangle data. PITcleanr doesn't actually do much analysis itself. The goal is to prepare your data for other analyses. So it has a number of different tools. Like I said, it's kind of a smorgasbord, depending on the kind of work you're doing, your questions, the analysis you have planned. You might choose to use some of these tools, not use others. You might flip in a different question for a different project. And so the goal today is to kind of, give you bits and pieces and explain some of the tools that are in here and see if any of them speak to you as, oh, that would be really useful. I'd like to come back and dive into that a little more later on. Start off and mention, I mean, it is an R package. It uses R. It brings your data into R, it manipulates it within R, it prepares it for either spitting info or spitting outputs from PITcleanr into other R packages for analysis, or exporting it to other files, like an Excel file that you could bring into other software if that's your goal, right? But it is for R users. If you're not an R user, PITcleanr may not be for you, but hopefully somebody you work with might find it useful. So that's the caveat to go with it. Just to give you a flavor for some of the things that we're going to be talking about and some of the capabilities contained within the package. It has a number of functions to help query some data, primarily from PTAGIS. It has some functions to read in data, both from PTAGIS and non-PTAGIS sources, and put them into a standard format so that all of the other functions within PITcleanr can work on that, regardless of where your data originally came from. The big one that we'll talk about is about compressing those observations, reducing those redundant detections, shrinking those 681 detections in a 12-hour period into something like one row of data. Some of the other bits of functionalities, it can help determine your direction of movement. Are you moving upstream, downstream? We'll talk about how it can do that and some of the tools it can help to build the foundation for estimating those directions. It does have some functions to estimate array or site deficiency or detection probability. It's not the only way to do that, but it's one way, and we'll talk about what that looks like and whether that's sufficient for somebody's purposes. And also building capture history matrices. So that's often the input, a matrix of ones and zeros, often the input into a lot of mark recapture models. And so PITcleanr can help prepare your data in that format if that's what you're looking to do. All right, so let's start with just kind of going over some of the queries that are available within PITcleanr. Again, the goal here is to have functions that bring data directly into R when you're working with it. A lot of it is querying data from PTAGIS. A lot of those PTAGIS queries are hitting PTAGIS's API and just making use of that, which is wonderful. So one of them is pulling in all the site metadata from PTAGIS across all PTAGIS sites, which is great. It can be really useful. We'll show kind of how that's used in some functions, some other functions later. You can also pull in some tag details. You can pull in mark, recapture, recovery data files if you know the file name. There's a function to query timer tags for a particular site. The way PTAGIS's API is set up, my understanding that basically put in the site and it pulls it down for an entire year. So just be warned that can take a little while. There's a couple other smaller ones that are included, this cap history and query tag events. They do require a PTAGIS API key, which you can just request from PTAGIS. Which is fine. I will say when I asked for one and talked to them about those particular queries, I said those are great. Please don't use those in a loop to query 5,000 tags and get all of their capture histories within R. It's our website's not made for that. So, and that please use the request was please use our download tools, and we'll show you what those look like in a sec, right? But for an individual tag or two, that can work pretty well. The other query that's in there is to pull in flow lines, so NHD plus stream layers from the USGS. There's a query in there to do that based on the sites that you're interested in. So we'll look at what that looks like in a little bit too. All right, so I wanted to show a number of these functions using an example data set to just play around with a little bit for the purposes of this talk. This data set, it's included in the PITcleanr package, and it's for adult spring Chinook that are returning. They're coming into the Wenatchee River in the upper Columbia. They're being tagged at Tumwater Dam, which is the site labeled TUM. They're about a third of the way up the map. And then we're tracking their movement and getting detections of those tags at all of the other sites on the map there within the Wenatchee Basin. And the goal is to estimate movement or survival past each of those sites, translate that into abundance estimates while accounting for the fact that there's imperfect detection probability at all of those places. Again, I'm not going to talk about the actual model and how you generate those estimates, but I'm going to talk about how PITcleanr can be used to clean up your data from the very beginning to get to the point where you can actually run analyses like that. We'll start, we need to get some data. We're going to read that in from PTAGIS as complete tag histories, right? And if you were here a couple weeks ago when Nicole was showing some of the PTAGIS web interfaces, you might recognize this screenshot. This is from just running a complete tag history query. You can set up a report like this. You generally need to start with a list of tags. So, that's probably an initial query from PTAGIS or something else. You start with that initial tag, and then what PITcleanr really needs, it needs a few particular columns to come out of this, including your tag code, your site code, the exact date and time, what antenna that observation was at, and what the antenna group configuration was. And we'll talk about what that means in a little bit when we talk about some configuration files down the road. You are welcome to add any other information that you want to this query. PITcleanr will can just bring it along for the ride. If you want to know the mark species, the mark date, the release date, release site, anything else that you can think of, event, latitude, longitude, any of those columns in the left-hand side that you want to move over into the right, that sounds great. But these are the 5 that you really are essential if you want to make some of the functions work. So once you have that, you've downloaded it from PTAGIS as a CSV file, right? And you call it something. In this case, I downloaded it. I called it this file name, Tumwater Chinook, complete tag histories from 2018. This file is included in the PITcleanr package. And so here's the R code to run it. And I'll point out for this talk, since this is an R package, there's certainly lots of example R code shown on the slides. Anything highlighted in yellow here just shows a function that's specific to PITcleanr. So, hey, this is what you're getting out of this package, right? And so that first bit is just saying, find this file because it's within the PITcleanr package. You might say, hey, find it on my desktop if you've got your own file that you downloaded. And then it uses this read CTH or read complete tag history function. And that's what pulls it into R. You'll see the file type argument there. The default is set up to say that's PTAGIS data. PTAGIS is not the only format, right? And that basically just says, hey, I know what those column names look like. If you download it from PTAGIS and you have those certain columns, it's going to go look for those and make sure that they're there. But it's not the only file format. If you download data from Biologic, it can read that in. If you download raw data directly from a reader and it's coming in like a .log or a .text file, it can read that in. And there's just change the file type, right? But again, it puts that into a consistent format so that other functions down the road within PITcleanr will all work on that, regardless, again, of where your data came from originally. All right, big key feature, I think, for PITcleanr is compressing that data, right? It's shrinking it down into something that's hopefully more useful. And the way it does that is map each site and antenna to a user-defined node. We'll talk about that in a sec, but essentially you have a lot of flexibility in how you want to define that. For this example, we define that as a node was the site. So the actual PIT tag antenna site or the site code. And when we compressed it, that initial data set, we went from 13,500 observations, compressed it down to 4,400 rows, so about a third. And that significantly shrinks it. The output of that compress looks something like this, where you've got a row, you've got the tag code, the node, whatever you mapped it to. So this is very much user defined. You could call this anything you want. In this case, I have called these by the site code in PTAGIS. The slot is just, hey, puts kind of in order for each tag. They all start at slot 1 and then however many detections you have. The event type name, was it a mark, an observation, a recapture, recovery? And then sort of the first detection, the last detection at that particular node, and how many were contained within that, right? So you can see this, the second line, there were 18 detections of this tag at site BO3 between those 2 time periods. And then it also spits out the duration. So that's basically the last time minus the first time, or the travel time, which would give you the last time at the previous node to the first time at that node. And so you can see again, in this example, this fish was marked in 2016. And then you can see its first detection after that was at Bonneville at BO3 in 2018. So that's a long travel time. The default units for duration and travel time are minutes. So that travel time is a lot of minutes. You can change that. There's a argument in the compress function. You can make those default units anything you want: seconds, hours, days, weeks, years. Again, whatever would make sense to you, or you can certainly manipulate it after the fact, right? The other thing I just wanted to point out, if you added up, you summed all of the numbers in this N detection column, you'd end up with the number of rows in your original data. So I mentioned that just to show that this compression accounts for all of the detections that you had in your original data. You don't lose anything from it, but hopefully it shrinks it into something that's a little more manageable. Sum it up again, I think this is kind of one of the keystone abilities of PITcleanr. Shrink that size of your data, can really map to the node of your choice. And we'll talk about what that means later, because that can be really important. It has a lot of flexibility in how you do that. And then just provide some hopefully useful information along the way. So let's talk about how to build that map. So this configuration file is what I've called it, and it's mapping those detections to a user-defined node. So that's every site and antenna combination maps to something, and that node could be, I want to keep it at the individual antenna scale. I want to group it to or map it to a group of antennas, like an array, an upstream or downstream array. I want to map it to the site scale. Just the node is defined as any detection within that site. Could be a group of sites. I want to, one node is all of the sites in the Lemhi River, for instance, or anything like that. And when you build that configuration file, your nodes could be a combination of these. You might have some nodes that are upstream, downstream arrays. You could have other nodes that are all of the sites within a basin, right? It kind of depends, again, on the question you're interested in, how you want to summarize that data. You can build that map to your specifications. So there's a default option here. You can use PTAGIS site metadata to construct that with this build config function. The node assign, there are some default options or some potential options here. One is to, hey, assign it to the site code. All the nodes are assigned to that site code. Another one is an upstream, downstream array. So if you have groups of antennas, it'll try to assign it to that. You can also go back and then manipulate it however you want after the fact. The output of that looks something like this, where you've got a column for site code, a column for antenna ID. This configuration ID, right, that's, if anybody's not familiar with that, that kind of defines a code for a particular site saying, hey, this is how the antennas were configured under this configuration ID. And that's really useful because some sites certainly get updated over time, right? And you might start out with a site with an upstream and a downstream antenna, 1 and 2. That sounds great. Later, a few years down the road, you expand that site. Now you've got 6 antennas in 2 different arrays. And now antenna number 2, instead of being the downstream array, is part of the upstream array. And so you need to might want to change how you map that. And you do that by saying, hey, there's a different configuration ID. And that is also what comes out when we pull data down from PTAGIS in that complete tag history, that antenna group configuration. That's this configuration ID. So it knows, hey, when this tag was detected at this site on this antenna, this was the configuration that it was under. And so that's how you help map it. And again, to this node, which is whatever you define it as. In this example, you'll know the node is just matches up exactly with the site code, but you can define that however you would like. When you run that build config file using PTAGIS sites, it includes a bunch of other information as well. You can see those first 4 columns are the essential ones, but it also tell you the start and end for that particular configuration, what kind of site is it, the name, the description, the latitude and longitude, which can be really useful. And oftentimes, for a lot of my analyses, I might start with that output from build config. And then I need to modify it to some degree, right? I want to either correct something because some of the PTAGIS metadata wasn't exactly right, or I want to combine some sites or flip some antennas from this node to that node. And so, I often write some script to modify that within R, or you could download that file, write it to an Excel or a CSV and manipulate it in Excel and read it back in. You can build it by hand yourself in Excel and read it back into R. You just need those first 4 columns, really. So again, there's a lot of flexibility there. But that is one of the key inputs, right, to the compress function. You need that configuration file. Okay, that's, I think, the heart of what PITcleanr can do. And then the output from that compress can be used for a bunch of different things. One of them, we'll talk about directionality. If you want to look at our fish moving upstream, downstream between detections, you need to know, okay, how are those sites configured, or how are they on the landscape in relation to each other? What possible paths might a fish take to get from one place to another? Where might it be detected along the way? So to translate that kind of spatial map of sites into that sort of information, I've called it, building a parent-child table, essentially building a table like the one here on the right, where tags are moving from parent sites to child sites. In this example, and by default, I'm thinking about adult fish. So parent sites are generally downstream of child sites as fish move upstream. You can easily reverse that if you're more interested in downstream movement. But you can see every site in our example here shows up in the child column once. The only one that's not there is the initial site, Tumwater, because it doesn't have a parent. So they're all in there once, and you can see where the site was that where fish might have come from to get there. You can also see, some sites show up more than once in the parent column, like Tumwater has 5 different sites after that. Why? Because there's branching in the stream network. And so fish that are detected at Tumwater might show up in one of those 5 different child sites. That is the entire parent-child table for this example. I mean, that's fairly simple. You can build that by hand, either in R or in Excel. You can also use PITcleanr. It has some tools to help you build that. And when you think about some of those other examples, if you're dealing with hundreds of sites across a large landscape, it might be a lot easier to use some defaults. So it has a build parent-child function. You need to make some of your information spatial. So you need a spatial point object of your sites. I'll show you how you can build that. There's a couple different ways. And then you need that spatial line object of flow lines. And that's where that query flow lines function comes in. I'll show you what that looks like in a sec. So building your spatial object of sites, one way, there is a function in here to say, hey, after, from my complete tag history file that I've downloaded, this is all my data, extract all the sites where I have detections. There's a function for that. You can make it spatial. You can kind of say, I filter out all the sites that happened before a particular date. And there's all of your sites. So maybe that's sufficient, right? And then there's some manipulation down below that I did to make sure they were only within the Wenatchee Basin. Or you could build it by hand. Here's one way to say, hey, here's a list of site codes that I'm interested in. And then we're going to attach it to some of that configuration information in that configuration file, particularly the latitude and longitude, and make that spatial. That might be another way to do it. Once you have those spatial sites, or sites as a spatial object, you can use this query flow lines. It takes those sites and says, oh, okay, let me grab you all of the stream layer that will connect those sites. And it tells you where to, you tell it which site to start with, like at Tumwater. So it'll go upstream from Tumwater, query all the stream layers above that or upstream of that. It'll filter it to this minimum stream order. So you can have some, you don't need the tiny tribs. It's great. It'll just make that object a little bit smaller. You can pull that out. The important output here looks like this over on the right. And that's really, for our purposes, what we want and why this query flow lines is important and not just any stream layer, is that the NHD plus layer from the USGS, every little reach on there has a hydro sequence. And it also tells you for that hydro sequence, what's the hydro sequence directly upstream and downstream. And you can see, those aren't in any particular numeric order. So you can't just look at it and know. But from this lookup, you can tell, and PITcleanr uses that information to sort of walk up and down the stream and determine which sites are connected to which other ones. So the function is, once you have your spatial sites and your spatial stream layer flow lines, you can build a parent-child. You can edit that parent-child, right? So there's a function to help do that and manipulate it a little bit. Sometimes that helps because sometimes the lats and longs from latitude, longitude from sites isn't perfect and it gets snapped to the wrong place. Sometimes, like in this case, there are some sites downstream of Tumwater that I actually, because some fish fall back and move downstream, so I want to treat those sites as children, even though by default, the build parent-child function won't do that. So I manipulated that a little bit, and you end up with, again, this result here. There's a function to kind of plot that, kind of take a look at it. So that's the default plot. You can make sure, oh yeah, that's exactly how I thought my sites should be arranged, or no, this one's actually not connected the way I want it to be. Let me go back and edit that parent-child table again until that looks right. Once you have that, you can also build the node order as a function that will tell you in particular the path that a fish or a tag might take to get to any one of those nodes. So you can see, say down at the bottom, site WTL, fish has to go through, starts at tumwater, has to pass through UWE, and then finally gets to WTL. So we can kind of tell which sites are kind of along the way where it might get to. Once you have that parent-child table, you can add direction to that compressed output. It looks something like this, where fish start, and then you can see, oh, they're moving forward. You can see the path they must have taken to get to that particular detection. One to point out, some fish do some strange things. So here's an example of one started out at tumwater. It moved forward to UWE, moved forward again to NAL in Nason. Well, then it jumped back into a different tributary in LWN. So hence the direction is unknown. And it jumped back into NAL. Then it went backwards downstream to UWE and then finally forward and forward again. That might be useful information in and of itself, depending, again, what your question is, right? And this is an example for spring Chinook. I'll point out when I run similar analyses for steelhead, you get a lot more weird fish, not weird fish, fish that are doing strange things going on. I'd like to call it walkabout, but I guess it's swimabout for a fish. And again, that might be enough information. That might be all you want to know is, hey, how many fish are moving up and down, backwards, forwards? How many times are they jumping tributaries? If that's your question of interest, great. For this particular analysis, I needed to come up with a data set that was assuming fish were only moving in a one-way direction to their spawning grounds. And if you included detections that looked like they were bouncing into different tributaries, it was going to break the model. So PITcleanr has a function to filter those detections and make them into, or to help you come up with which ones do you want to keep. When you run that function, it attaches two more columns to the output, two different keep obs columns. The final one is a user keep obs. That's your choice, your kind of final call. And then the auto keep obs is one that's PITcleanr's best guess. And for all of the fish that do very straightforward movements, both those columns are completely filled in. You don't have to worry about it. For any fish that does something a little more strange, the user keep obs will all be NAs for that particular tag. The user keep obs, or the auto keep obs, is filled in. It's PITcleanr's best guess, as I said. And so you can see in this case, kind of assumes that last most upstream detection is what you want to keep the most. And so it's keeping the detections that lead you or lead that tag to that spot and trying to delete everything else. This is where I would take this information and hand it to a local fisheries biologist who can look at the tag sites or the sites and the date and times of those and kind of try to make a judgment call as to which of those, where is that fish actually spawning, which of the detection should we keep. And they fill in the user keep obs column and then send it back. Again, I don't know how frequently this would be useful for folks. I do this quite a bit for similar type analyses. Some of the other functionality in PITcleanr, they mentioned there is a function to estimate array efficiency. It's based on the tags detected at an array and any tags detected upstream of an array, or at least, I mean, I'm thinking of upstream again because that's how I've set up the parent-child table. If you had it flipped around, fish are moving downstream, then it would do that as long as your parent-child table is set up correctly, because it's going to start with that build node order. So it's kind of building that description of what path might fish take. And so when you look at this, and if you look at any particular node, you can see, oh, these are all the places a fish might be detected after that node. In this case, upstream of that node. And when you run the function estimate node efficiency with that node order, it's going to essentially compile how many tags were seen at a particular node, how many tags were seen above that node total. Of the ones seen above that node, how many of those were resites? So tags that were also detected at your node of interest. Those three bits of information, essentially like the M, C, and R in a mark recapture model. We use a simple mark recapture estimate of total abundance, estimated tags at your node. And based on that, you saw so many at that node. So there's your detection probability or your efficiency estimate with some standard error that comes with it, right? You can see for some of those nodes have pretty high detection probability and some of them are pretty low. Again, this is not the only way to estimate detection efficiency, right? And it kind of assumes it's the same for whatever time period your detections are good for. But it's one way to do it. And it might be a straightforward way to at least pull some ballpark estimate out, right? The other thing, I think one of the last functionalities I want to talk about is generating these capture histories. As I mentioned, a lot of mark recapture models need a matrix of ones and zeros, like the output in the right-hand column down below here. And so you can build that with PITcleanr. It's got a build cap hist function, and it spits out a row for every tag. And then here's your capture histories of ones and zeros. Right now, I had somebody ask me this the other day. Right now, that capture history is all spatial. It's all based on each column represents a site, which for PIT tags is often one way we look at it. I think there are ways to manipulate this to turn it into a temporal capture history. You know, I've seen it this time period, this time period, this time period. It's something I'd like to work on in the future as an option. But for these fish, great, you've got one row for every tag. Important bit of information then would be, well, what does each column in that capture history matrix stand for? There's a defined cap hist columns that comes, you can run that. The output looks something like this. And this is telling you, great, that first column represents Tumwater, TUM. The second column represents site CHL. The third one, CHU. And again, those are nodes that you defined in your configuration file. So however you built that, that's what's going to show up in these history columns. And you can spit that out, again, either into another R package that runs mark recapture models, or you could export that to Excel if you want to bring that into something like Program Mark. You can also add, if you have other information for individual tags, like covariates like length of tagging, when it was tagged, species, origin, sex, anything else like that, it's pretty easy to attach that to the tag code if you have that. So that was a whirlwind tour of a lot of the stuff within PITcleanr. Hopefully it just, again, wanted to give you a flavor for what's possible out there. If any of that spoke to you and kind of rang a bell, oh, that would be helpful, or that I could see that being useful for this problem I'm having. Wonderful. Package resources are here to help you dive into that a little more detail. So there's a package website. Here's the link. You can also find it just directly through the GitHub source there. Let me just show you what that looks like. So on the first page, there's some installation instructions for how to install it from GitHub. It's pretty easy, one line of our code to get it installed. Then there's a bunch of other pieces of this website. One, if you click on the functions, it lists all of the different functions. They're kind of grouped by their general type. So here's a bunch of query data, query functions, helping to build parent-child table type functions. And if you click on any one of those, it kind of takes you to the help file that you can also get to directly from R. The more important bit that I want you to focus on if you come to this website would be under the vignettes. This is where you can find a lot more information, a lot more detailed write-ups, right? So we've got a one that kind of goes through a lot of what I talked about today, but in written form. It's got the R code to kind of show you how it works, and written out detail around what's behind each of these things if you want to refresh your memory, and so on and so forth. There's some more specific, and that one's pretty big. It goes through a bunch of different functions. There's more specific components, so getting into different ways, different types of PIT tag data, how to read those into R, how to build configuration files, a little bit more about compressing that data or building parent-child tables. If you're interested in running the dam adult branch occupancy model, which is what I was trying to do with the Spring Chinook data set, there's a whole data prep cheat sheet for that. And then we also gave a workshop, not just a talk like this, but a whole workshop in the afternoon at the PTAGIS conference a year ago, and developed a big R script that used example files that are contained in the PITcleanr package, or you can bring your own and easily read, start with that, read those in, and then follow along through all of that code and various functionalities. And so that is all here as well. There's that vignettes page. Other resources, you can certainly contact me. The other folks who have been really instrumental in helping me build this package are Mike Ackerman and Ryan Kinzer, work for the NES Purse. There's their info. They said, I've really tried to make PITcleanr useful for other people, not just myself, and make it generic enough that the tools are useful for other people. So if you have questions about how to use it, or you have suggestions about, well, I'm trying to do this and I don't think PITcleanr can handle it, but it would be really useful, love to talk to you, maybe incorporate that kind of new functionality into the package in the future. With that, if I have any time, I'm happy to take questions now, or certainly wait around later as well.
I think we have some time.
Wonderful.
First of all, thank you so much, Kevin. That was awesome. Amy's going to drop that link there in a minute here. There you go. And we'll share the slides, etc. later. But thanks to Kevin and for providing his contact, and also your colleagues, Ryan and Mike. It's really amazing stuff. We're delighted to see the demonstration of use of Git. Right, it's very nice. And Ben mentioned that last week. So we're tying all this stuff together. You guys are doing an awesome job. I did see one question in the chat from Ralph Lampman. It was a while ago. It was regarding, I'll just read it. Doesn't PTAGIS summary interrogation data provide this info, and then parentheses, except you have to set up calculation for travel time yourself? So that was a little earlier in your presentation. I don't know if you addressed that kind of along the way. Right.
I think there's a lot of information you can just pull down directly from PTAGIS. And a lot of those queries, yes, it does contain some of the same information. Part of my goal in writing, PITcleanr is in R package, so part of it is to try to help pull stuff directly into R. And again, depending on your question of interest, like if it's a simple one like that, then maybe just a straightforward query from PTAGIS is sufficient, and that should be good to go. And you might not need PITcleanr at all, right? And that's great. That makes your life a lot easier, maybe more simple. This was just things that I was pulling in to manipulate your data and make it, maybe for other analyses down the road.
Perfect. Hi, Graham. Go ahead with your question.
Oh, how you doing? Thank you very much. Thanks, Kevin. That was awesome to see that in detail. I've got, I guess, a couple of questions and comments, maybe more. So I'm doing this exact job just now in a much smaller scale. We've got a couple of catchments in Scotland that have one of them has 4 sites, the other one just has 2 sites. And I did look at PITcleanr before I started, and was really interested in the node mapping, but time constraints meant I just had to basically crack on and do it, because sometimes it's just harder. You think, okay, I don't have time to learn this, but I think I definitely could have used the PITcleanr tool. But I guess what I'm wondering is a couple of things. So the project I'm doing, we're looking at the full. We tag the fish as par, and they go out and come back in again, and on occasion they go back out again as well. So we look at the full kind of up down, down up down potentially. And you mentioned that you can switch to child parent direction. Is there a way to kind of do that in PITcleanr where you look at the down and up in kind of one query, or do you have to separate it out into 2 separate queries?
No, that's a great question. So I guess it depends on how your detection sites are set up. And then I know I've run some analysis looking at where they're tagging juvenile fish as par or smolts, and you get detections as they go downstream through some of the main stem dams, like through juvenile bypass on their way out. And then we also get detections at some of the adult ladders as they come back as adults. And that, for examples like that, the juvenile bypass and the adult ladders have different site codes in PTAG. So the data is stored and it's coded a little differently. You can actually treat them as even though spatially they're in the same spot, you can treat them as different sites and kind of set it up as a kind of a long chain of potential sites where you have the kind of adult detections well after the juvenile ones.
Mm-hmm.
But I think if you had it like in the same spot, same site code, I think it's, I mean, you could, if I'm understanding your question correctly, as long as, I mean, if you code it up, it would just look like, I mean, you got to pick which direction you want to call forward, right? But if it's forward as you're going downstream, going out as par, then backward would just mean they're coming back as adults.
Okay,
and that's, I did try to, at one point I had that direction function spitting out like upstream, downstream, and realized, well, that depends on how you set up your parent-child table. And so now it's just forward, backwards, and that's totally up to you and how you arrange that. And then you can interpret what forward means and what backward means because you set it up that way.
Yeah, so you could just basically choose one and the fish will do what they want, and then you know what forward means. Oh, okay, so it will basically string those together.
Yes.
Okay, that's quite cool.
Yeah.
So what I'm doing is I'm trying to incorporate, and I work in R and trying to incorporate a little bit of life stage classification as well. So as they go out, so this, I guess, is more of a comment. Like, you know, I don't know if you've thought about having something like that where if you tag them as par, something that classifies them as early par movement and then smolts on the way out and then adults on the way back, and you know, getting even more complicated if you wanted to. That's,
I mean, I think you could. I think part of the so one of the outputs from that compress, or certainly one of the outputs from the, when you get to the add direction, right? It'll always say start. It'll you know, which row corresponds to generally the tagging detection. And so you could look at that and say, you know, write a little bit in R to say, okay, every detection that is within a year of that start for each tag is juvenile, and everything after, you know, set your own threshold for how you want to divvy adult and juvenile up. But I think it would be pretty easy to assign a label to each of those rows as, is this a juvenile detection or an adult detection based on that.
Yeah. Cool.
Yeah.
And last thing, sorry, I've taken a lot of time, but do you ever encounter, and this is probably to the whole PTAGIS community, I know PTAGIS is quite strict on the code formats. In fact, so strict that you only have one format. But we have an issue where there's quite a lot of different formats getting used in and around the Atlantic. It's all the ISO 11784. I think that, if memory serves right. So we sometimes have to convert the format from, say, decimal to the, I think I can't remember the name of the format you guys use, but it's probably the PTAGIS format. But there's also two other formats, which is kind of a full hexadecimal, depending on whether it's reversed or not. And so this is more of a comment, and I've created an R package that does that conversion, and it's such a small package that it could be something that we could actually just plug into PITcleanr, something that maybe something we could have a chat about, because, you know, the package I've created is very tiny. It could just be a good bolt on for you guys. I don't know if it's a problem you guys ever have though, the format conversions.
I mean, I could let anyone else chime in, but my experience, you know, if you're dealing with data within the Columbia Basin, within PTAGIS data, it's pretty regimented. Yeah. But yeah, I mean, my goal with PITcleanr is to make it as flexible as possible. So yeah, we should definitely talk. I'd love to figure out how to, whether it's incorporate your package, you have calls to it, or at least link to it and put some resources like up on the installation page for PITcleanr saying, hey, this could be really useful. Yeah, I'd love to talk more about that. You want to send me a message sometime soon.
So yeah, I'll email you the details of that.
Cool. Great.
Awesome. There we go. International expansion. Very cool. I do, and we have office hours at the end, so we can circle back. There's one other, I think, a short question for Kevin. Then we're going to switch to Brian here in a second. Thank you, Graham. Okay. Brandon's asking, can the package draw pictures of the stream networks?
It draws pictures like this. Can you guys still see my screen? So it plots your nodes like that. And
We're seeing the question slide. Are you on
okay.
a different screen or something?
Gotcha. You can do that plot nodes and it'll spit out that kind of generic map of, oh, I see.
Let's see.
There we go. Right, a little node package like this. I mean, this doesn't tell you exactly where it is spatially and so forth, but at least how different sites or nodes are related to each other. If you're talking about, maps like this, I mean, I plotted that using the stream layers that I downloaded, like the flow lines, and the sites, spatial objects that I showed how to construct. That was just using ggplot based on that.
So yes, sort of all of the above.
Yeah,
Sounds like there's an extra step to get to this pictorial with the flow lines, but the other one shows the relationships, and that's pretty straightforward.
I
Brandon
like making
says,
maps like that, but yeah, I mean, other people like to plot their spatial networks or their stream networks a little differently, so I figured I'd let other folks go crazy with that.
Awesome. All right. Well, I'm going to wrap it up with Kevin, but stick around, Kevin, please, and everyone else. We should have some time after Brian Maschhoff presents, and we'll have some more discussion. So next up, thank you, Brian, for joining us. Brian Maschhoff with Salmonetics. I think his title was Strategies for Bringing PTAGIS to the Masses, and he's also going to show some tools. So thank you, Brian. I'm going to shut down my camera and take it away, please.
Okay, let me get to the sharing portion here. Screen. Start the slideshow.
All right, I can see it. It's great.
Okay, first I'd like to thank Bonneville Power Administration for supporting this work. My job here is to convince you, unlike Kevin, who is a little bit ambivalent, I'm going to convince you that you really need Pithy because it's really going to change your life. So I'm going to talk about what Pithy is and why do it. I'm going to go over a couple of examples that were done a couple of weeks ago by Marika and Nicole, and I'll explain the reasons for kind of going over those again and as a way of kind of demonstrating Pithy. Some ideas for the future, and some talk about using GitHub and other ways of trying to maintain the momentum on this project and others, as well as maintaining integrity of data or reproducibility of data across everybody's work. So Pithy is designed really as a tool to use when you really don't have any idea of what you're going to be doing with your PITtag data. It's a way of looking at the data, getting an idea of what's there before you actually begin your analysis. And it's useful for not just people who have a specific tool in mind, but people who are curious about what the data looks like, but also want to clean it up, maybe to use for other tools. And so I started from a different direction than Kevin with PITcleanr, in that I wanted something that was easy to use. It's drag and drop. You don't need to know Excel or anything. Just had a web browser, and it assumes that you know how to get stuff out of PTAGIS, but beyond that, you just basically drag a file in and it loads it up and shows you what the data looks like. And there's various ways of looking at the data. There's additional capabilities to download some other data from Dart, for example, temperature data, which roughly corresponds to the same locations and time periods of the detections, and to be able to export the data to do some kind of round trip work about data in, data out, do something else with it. I'm going to talk about more deep cleaning rather than just think about removing the superfluous detections, as Kevin talked about, but also identifying data that you don't want in your analysis, that you might not expect to be there, so you might not be looking for it in a particular way. So how do you identify that data to be able to get rid of it, resave your data, and then go on with your work doing something else? And secondly, is to be able to really understand what you just downloaded in terms of the science and the fish, because there's, thinking about both in space and time, there's a lot of stuff going down, and even from simple PTAGIS queries that you might not be expecting. And some of that is again superfluous or maybe kind of a mistake. Some of it is actually very interesting fish behavior that you might want to explore further, or it might change your ideas of what your analysis is going to be. And some of it has to do with the way data is in PTAGIS, because it's a huge database with all kinds of fish and detections, but they're often tagged for different purposes, different ideas or needs in mind. And so sometimes when you combine a lot of different release groups or detections in one particular group, you're really doing a meta-analysis that you need to understand that there might be some differences among the release groups, for example, that might turn into latent variables in your data. It's causing some differences that are due to those differences in the way fish were tagged or whatever, that explains the data and you're not anticipating that. So it's good to understand the context, and Pithy kind of helps you do that by looking at the data overall and being able to explore different parts of it and see what's going on. So in terms of showing the tool, I'm going to start with a couple of examples that were done by Nicole and Marika a couple of weeks ago. And in Marika's case, she was simply looking at observations at a particular couple of sites on the Loxa River in a couple of different years for steelhead. In her example, she did some Excel processing that with the interrogation detail query that she downloaded. And at some point, she took the unique tags from that and did another PTAGIS query to kind of identify something about those fish, and she created some summaries. So what I'm going to do is switch to this particular site here. Let me get rid of that first. Okay, so this is an example of what happens when you bring her data into Pithy, but I'm going to start with a clean slate here, and instead of starting from that point, I'm going to start from this file right here. So I have a file which I have downloaded from PTAGIS. In this case, I reproduced the query that Marika did on the PTAGIS site. I grabbed all the fish instead of just the steelhead. In this case, I actually just grabbed her file, the steelhead. Let me back up and just grab the full one here because it's a little bit more interesting. So here, what I've done is I've dragged the file onto that site at the beginning. Here, I included all the fish, not just steelhead, but also Chinook and steelhead. And the first visualization that shows up is a map showing where the various events are in the complete tag download from PTAGIS. And I have included various different types here. I have releases, observations, including recaptures and recovery. And so to kind of start here and observe, looking at what's going on here, I'll just look at the releases. So I'll check both of those. And so again, this is including all steelhead and Chinook, but if you see what's kind of interesting here, we're starting out, we are just interested in looking at fish that are detected way up in the Loxa River here. And we have, but we have fish which are been actually released up in the Yakima Basin, well, some down at the Bonneville adult fish facility, the trap as adults going upstream. We have fish that are released in Lower Granite, and then one fish that's released in the South Fork. Trimming these down to steelhead, let me get rid of this label here. We find the release groups that correspond to the fish for the steelhead. Next, we can go and look at the what I call the fish tracks. And this represents for each line connecting the dots represents a single fish. And so to examine some of these, there's different tools to be able to go through and look at it. But for the most important one here is we could either do some additional filtering on the data to, the release basins and release subbasins are involved, and changing some of these will reduce the number of fish that you see. You can drill down into various release years, so 2024 instead of 2023, for example. Once you've come up to some idea of what you want to look at, you can start refining further. For example, I can select these fish here. So now I have gone from 132 fish in my original set that were at in 2024, 105 fish, and I can see where those are at. What I have on the y-axis here is all the sites, both the release groups and observation sites, which have been linearized in a particular way. Now you can imagine yourself starting at the Columbia base at the Columbia River mouth and proceeding upstream, and every time you hit a tributary where there's sites on it, you go in that direction. And secondly, these have been grouped into convenient groups that represent collections of sites. To expand each of these out, I can click on the particular supergroup site, and the groups that were within that site show up below. This is a manual configuration file which has been set up in Pithy that has to be maintained as new sites are added, and that causes a little bit of a maintenance headache. But it's worthwhile to be able to get the direction. So unlike in PITcleanr, what this site does is it represents the site spatially, or the directionality within the configuration file. So that, for example, you see fish that are here tagged at Lower Granite Dam and going upstream, the lines go in a positive, an upward slanting direction toward the upstream sites. I can also expand the ones up in the cellway, and it works both ways. So I can identify the sites that have been observed at the lower Loxa River site, the upper site here, and you can see how they differ from the ones that are observed at the lower site, and you can see that there's interchange between them. So there's a lot of different analyses that you can do just within this, seeing what's going on. But I want to emphasize the utility of this for being able to select particular groups of fish that you're either interested or you're not interested. And beyond being able to do things like identify fish that have been detected at certain locations, you can also create an advanced query. In this case, a true fallouts option, which I'm going to look at fish that have been detected in a particular sequence or a particular place. So if I'm only interested in the fish that were just detected at this dam, I can select those fish. And what that does, this little box, once it's on there, it has put these particular fish into a buffer. These 104 fish, and I can call that a name over here. I'm going to say LRU, and I create that new filter, and it creates a new pie chart filter that lets me select just those fish. So now if I click true on that, I have filtered my data set to just include those fish. Then I can export that in different ways. And the export button is located here under fish filter, and clicking that gives me several options. There's a couple files that are JSON files that actually maintain the grouping of fish. But I can also save it as a PTAGIS raw, which basically outputs the same format that I started with. And clicking that, it'll download a particular file to there. One other option, though, is if you're interested in getting additional information about those fish that maybe weren't in the original PTAGIS query, I can copy the tags of these fish to the clipboard. They'll say okay, and then I can go over to PTAGIS, and I can, as Nicole showed a couple weeks ago, I can go into here and number 29, paste those fish here, and then run a query. It's not going to be called punwetter. Unfortunately, the waiting time is this. It's not really important. I got booted off of PTAGIS here. But let's just go back here to where I was talking about the file. One note about what Kevin referred to as a the cleaning operation is removing the multiple detections between a site. The way I handle that in this in my application is what I call it is pruning. Right now, I only have the option of either pruning the site at the site level or none. So in the future, I want to add additional capability. For example, pruning by the antenna group or the antenna. But in this case, what this does is essentially achieves the same thing that PITcleanr does. The only difference is that I maintain 2 rows for a particular site in this case that occurs in a particular time, and instead of 1. So I maintain these basically with the first and last detections at a particular site upon a particular direction. And the notable thing here is that because I have, when I go through and calculate those particular tracks, if a fish does encounter, see if I can find one with a, you can't, sometimes you can find fish that have reascended or fallen back. And that's kind of, here's an example here. So these might be at a different sites, but if fish is going up and downstream, it maintains these as 2 separate events, even though it's the same, it might be the same site. But the idea is that you don't lose track of any of the data or any of the up and downstream movement of any individual fish. But in the download, when you do download it as a PTAGIS raw, it saves it in the original format, such that, but it does maintain the trimming or the pruning of detections. So you basically do the same effect of reducing the number of data points that you have, making the data much easier to work with. And I can then, if I've saved this data, I can go back and reload the thing that I just saved. So for example, if I go back to my downloads file, identify the thing I just downloaded, and I upload it up here, I can reload that trim data set, go back here and see that this is what it looks like. So I think for most people, you'll even if you have other ideas for analyses in mind, it might be useful to first drag your data into Pithy and see what it looks like, identify things that don't make sense, and then afterwards export it and do whatever you were originally had in mind for it. The next example that I want to show is from Nicole, and she had a much more involved data set, had a lot more fish, 15,000 fish, with a lot more detections. And there were some interesting, things that I learned in trying to reproduce what Nicole did. And let me go back to my presentation and show a little bit of that here. So Nicole did a very similar thing. She did interrogation detail. This case only to get the tag attributes. She saved that as a static query, and then she went and did a complete tag history to get all the tags. And this was a particular site, and then she ran the query. And so this is what I get when I bring it into to PTAGIS. If I click on the fish tracks here, you see a much more interesting variety of things, mostly because we have detections at a number of different years. This included basically all the years that fish were detected at that particular site. I'll go and clean this up a little and only look at fish in 2022. And I'll look at only steelhead. And so, again, for the most part, we have very releases that are dominated by fish that are released from the ladders at the see, is that right? No, this is actually released in the lower snake. So you can see that's this particular site here where most of the fish are starting. Some of them are going downstream. After that, some are going upstream. You can identify fish that are coming back as going back outstream as kelts. Lots of stuff going on, but again, you can make sense of a lot of that by just kind of grouping, identifying particular fish. And I guess what I'm really impressed is that even for fairly simple queries like fish fillet at a couple sites, you get a whole lot of stuff going on. Sometimes a lot more than you can process. But if you have an idea what you want for your analysis, I believe it's better to start with getting all the fish, looking at the complete context of what's going on, making sure that the data that you want for your analysis is present here, and removing the stuff that you don't. Okay, back to the presentation here. A couple of let me I took this of Kevin's talk here, and I just wanted to quickly do that while he was talking to make sure that my data could be re-exported into Pithy after into PITcleanr after being exported from Pithy. And so I just quickly ran and did a demo of that. I took his I did a query at PTAGIS using the sites that he was suggesting, and I saved it into here. This represents what Kevin was looking at. They're basically the same sites. The fish tracks looks obviously complicated again. First of all, we have a whole lot of a number of fish that were detected years down the line. That kind of makes things a little bit crazy. But if I can go here and look at it, so you can see all the wealth of information of fish going upstream and downstream for fish that are released at the Tumwater Dam here. There's some interesting stuff here. There's fish that have strayed up to Rocky Reach Dam, come back down, made their way back up. Kind of an interesting core. We have lots of fish going out. Here's the fish that are going downstream after being released from Tumwater. So we have some that are going this way and they come back up. So there's a lot of motion of fish that are after they have been tagged at Tumwater Dam. But anyway, so I have exported this file from here, and then was able to do the task of uploading this into I'm not going to show that. This is just R, but I have uploaded using the Kevin's PITcleanr package. I was able to upload that, so it didn't do anything extraneous with the data. Back up a second, because a couple of notes that I put in from Nicole's presentation or observations that I made, because I had some challenges initially. What I first tried to do was just take a list of tags that I obtained and upload that into PTAGIS as she described in the presentation, or as I showed. You could take a list of tags, either upload a file or paste them in. And there is a limit of 15,000, but even at lower numbers than that, you can run into problems because a query using an uploaded tag list can take a really long time, and it's just a function of the way that the PTAGIS queries work. And a workaround that I found is that if you take a static query, create a static query instead using the tag list. That means create a static query that only has the tag ID in it and save that. And then if you run the query that you want against that query, it runs much faster than if you just run it on the uploaded tag list. Nicole might correct me, but I think that might be a good way to, if you have very large tag lists and you want to do a query with that either doesn't crash or that doesn't take a whole lot of time, you might try saving that query first as a static query. One other note is that Nicole also described either subscribing to a particular report that you've generated or a particular query as a file, such that it'll actually store a file on the PTAGIS server that you can either link to or refer to or point to other people. But I've discovered that the file that is saved and that you can download in that manner has a different attributes name than the columns if you do the manual download after you run the query. So just be aware of that if you have if you're going to maybe upload that into PITcleanr. I don't know if PITcleanr will be able to recognize that particular file names as correct ones for a complete tag history. Some other things for just getting an idea of if you want to explore around and poke and look at different fish behavior, is to look at the detections from the Bonneville fish facility or from the ones that are Lower Granite Dam. So these are adults that are coming back, and it's a good way of kind of orienting yourself about how many fish are going where. In the case of Bonneville, the detections going up the mainstream dams are pretty high, so you get a good rough idea how many fish are going in, past particular dams and in different directions. For Lower Granite, the detections beyond Lower Granite Dam are going to be influenced a lot by how the availability of detection sites. So what you get doesn't necessarily reflect reality, but it's still very interesting and puts your particular fish that you're interested in context of everybody. So for example, this is what, the fish from all the fish at the Bonneville fish facility tagged in a particular year. This is 2024 look like. This includes all Chinook, steelhead, and sockeye. And you can see a lot of the steelhead actually are, remain in the system and are being detected well into 2025 in this case. But there's obviously, much more going on here than you'd want to look at. But of course, going into bringing this particular file into Pithy, you can, slice and dice and whittle it down to something that's much more manageable to look at and be able to start exploring problems or see if there's something that you might have neglected in looking at your particular site. For example, fish that are in the same vicinity, are they doing something similar? And you might be able to beyond that. One thing I have neglected to mention so far is that Pithy has the capability of loading in files externally. And so I'll put all these things in the chat at the end here. People can play around with them. But this particular URL, if clicked on, will load Pithy and then load this particular file, which is on this file is on the same server as Pithy, and it loads up. And it basically will automatically load that data into Pithy, so that it's one way of being able to explore the concept of having a file out there that you want to show people what's going on. You basically give them a link to that file being loaded up in Pithy, and so they can, without any install or any downloads, they can just kind of quickly look at what's going on. I'll just quickly show being able to do that, being able to load this, and I'll just kind of Pithy. If you want to zero out the data, you can click there, or you can just, in some cases, you can reload the page unless it has the query string file attachment on it. Then it'll just load that file back up again. But here, I'll just load a different one here. I'll load this, the same one, the Bonneville 2024. And it takes a little bit, depending on the files, it might take a little bit longer to load. But that's the same file that we were looking at. Let's say if I just want to look at sockeye and get an idea. Sockeye is kind of interesting case. It's because we have most of the fish for sockeye are going up into the upper Columbia. Very few of the fish that are tagged at Bonneville actually make it into the Snake Basin. It's just a reflection of the fact that most of the sockeye going upstream are going up the Columbia. But there's a lot, interesting things going on. For example, in this case, if we're looking at the fish that are going above Wells Dam, this quite often happens that you have a bifurcation of the timing of fish going further up into the Okanagan, depending on what the temperatures are doing in the Okanagan. There's generally a break here where all the fish going upstream are hanging out just above Wells Dam in the cold water that's coming out of Chief Joseph, waiting for the temperature in the Okanagan to come down, and then they, as the temperature goes down, they go back up. So, I mean, one interesting thing to do is to be able to say, okay, I'm just interested in comparing these two groups and saying, okay, these are the early fish, and I could go and create an advanced query of those particular fish, and see how well they, compare how well they are making it into the upper Okanagan sites versus the ones that are later. There's different ways of processing that data later, but it's just a way, just within Pithy, without knowing anything about what you're expecting, to be able to identify groups, give them a new category, say, these are fish that I'm interested in, export them, do a different analysis, whatever. Let's see. In extreme case, you could open up 10 tabs of Pithy and have a different data set in each one. It's Pithy itself is fairly lightweight, but if obviously if you have lots of data loaded up into each one, things could get a little bit heavier on your computer. But the idea is that you could really do a lot of different things with just a simple functionality of that advanced query or the advanced filtering option, because you could take little groups of fish, save them, reload them up, kind of mix and match different groups, be able to say, okay, I'm interested in these groups. I want to see how they look. Just kind of play around with different ways of looking at the data without a whole lot of effort. And you could open and close tabs. It's something that's possible because it's just a quick, simple browser-based application. I want to talk a little bit about this tool and how to maintain it. Or Kevin had two other people working with him on PITcleanr. Right now, I'm the only person working on this, and I need to make this expand this out there in a couple of different directions. One, to be able to keep updating it and bug fix. There's, as I mentioned earlier, there's a couple of different configuration things that have to be maintained or updated every time new sites are added in PTAGIS. There's new metadata files that need to get updated. As Kevin shows, there's a way to do that with an API, so I want to explore doing that. More likely to use what Pithy has at the current time, and then check for updates and see if there's a new site. And if there's is a new site, it needs to be added into the spatial sequencing file that maintains a site order. And let me just show what that looks like. It's basically a JSON type file that has a particular grouping of sites. In this case, let's see the for example, the Okanagan River upstream, and there's the dams are down here, Priest Rapids Dam. Apologize for the wraparound here, but you can see that a given dam here will have a list of sites within that, and these sites are arranged from upstream to downstream, and so any new site just has to be placed in the proper place. For the most part, this file is derived from a alphabetic ordering of the RKM mask code that exists for all these particular sites. There's some places where it has to be hand tweaked, and that's usually done by observation as where fish are detected going upstream and in what order. But for the most part, it might be possible to, if there is a site that's not encountered, if Pithy is out of date, to be able to grab from PTAGIS the new site metadata and query that PTAGIS to get the RKM value and put it in a suggest a particular spot to put that new site. But this is just one thing that right now is necessary to go through every now and then, as sites are added and if queries manage to download data from that particular new site. There's also, I didn't show in this time, I had a presentation 2 years ago where I showed how how Pithy can download stream environmental parameters from Dart. There's a desire to have additional temperature information from other sites, and this would be sites upstream. Hopefully in the future we'll have more temperature information from additional PTAG sites. That would be great to bring those in. There is some additional information that's out there from USGS that I'd be interested in working with. And then the other thing that's related to that, but is still kind of an unresolved thing when you're thinking about temperature and flow information at particular dams, is there's more than one site available for that information. That's usually an upstream and downstream site at around a particular dam, and depending on what information you're looking at, the values are different. For example, if you're looking at dissolved gas levels, the downstream portion of the dissolved gas, or the downstream values are generally quite a bit higher, can be when there's a lot of spill going on, than the upstream. And it'd be useful to know what that is at the particular time that fish are in that vicinity. Now, do you have some kind of dreams? I'm not going to go through all of this, but there's things that Pithy can currently do and things that I would like to explore working with in the future. Mostly right now, it basically takes a complete tag history with a certain set of attributes that are in the help section of Pithy to show you which ones. It's pretty much the same ones that Kevin had with a couple of ones that he requested that have left out. There's some need for the other PTAGIS reports, for example, even the summaries, to be able to bring that data in and still make sense of it. And so there's a desire for doing that. Zip would be nice, just simply because it reduces a little bit of the time. But there's other information, as I described, that would be nice to be able to get from beyond the PTAGIS attributes. Work on some different ways of filtering the data to be able to identify, fish going upstream or downstream in a particular grouping, and identify or segregate fish that way. So I am working on a GitHub site for Pithy, and I've kind of got back forth in terms of how to structure it, because GitHub sites have a lot of different use cases depending on what people have done. For the most part, it started as ideas for open source software projects, where you had an application in the end and a lot of people working on it. More recently, it's a great place to put publication type information. If you have a publication, you can have data, you can have updates. You can also have source code used to create some of the publications. That's another good use case for that. And R packages, which are essentially GitHub repositories, and R just adds a few other things to a GitHub repository to make it an R package, but then that lets people download or install packages R directly from GitHub. But you can also mix and match some of these things, and one more sort of new possibility with GitHub, or at least one that's used in certain cases, is to actually make it a functioning site. Because GitHub has something called GitHub Pages, where you can publish a particular, either a branch or parts of a branch into GitHub Pages, which can be accessed as a website. It functions just as a normal website. It can load JavaScript pages and JavaScript files, etc. And one example of that, which served actually as the inspiration or the thing that I stole from the design ideas for PITcleanr, is something called Map Shaper. And if you're not familiar with it, you should be, because it's a very useful GIS tool. You basically take shape files, GeoJSON files, anything, and just drag them in here. It loads up, and you can quickly look at your GIS and do all kinds of very advanced functions with it. But let's see, it was over here. I'll just load it here. So Map Shaper here, what you saw on the website is actually running from GitHub Pages, which is located here. So this is the Map Shaper project file, or a project in GitHub, or the repository. You can see they have a number of contributors, 9 contributors here. They have the usual information, some that Kevin showed here. But down here, you look under deployments. This thing has most recently been deployed to GitHub Pages 6 months ago. So it takes the information that's here. Here's the WDFW portion of that. And then when the thing is ready, you just, it's gone through all the Q&A and everything. You can redeploy it to those pages, and and you don't need a separate server. It just runs off of GitHub. It's a convenient way of maintaining a website for a particular project or repository that has a lot more functionality than just the markdown stuff that you can put in the various markdown pages within GitHub. It could actually be running a web application, which I think is a useful thing if you don't have a good place to put whatever software or web project that you're working on. So this is what I'm probably going to try to do, or structure the Pithy GitHub repository in, so that it maintains not just the site itself in terms of all the thing, but if somebody just wants to run it, you can just go to the site. So it works as normal as any kind of website where you register a domain name. You can then point it to the GitHub page that you've created, or within GitHub you can just go to the same. It's a different URL within GitHub, but so you don't have to have a different domain name. Here I have a few links, and I'll put these in the chat just to make sure that people have them if you want to play around with them, as well as if you, I'll try to, I should have done this before. I put the links to some of these other, the sites so that people can play around with them maybe during the remaining time of the office hours, as they're called. And with that,
Amy's ahead of you, Brian. Amy Poles just dropped those links for you in the chat.
Okay, these are in the chat?
Yep.
Okay, I will go and drop some of the other ones in the chat too here. I'll go back and some of these other files if people want to load those things up while we're hanging out here. Here's for example, here will be Nicole's fish. I'll take that link.
Brian's grabbing a couple links from his many tabs open. Good job navigating all of that, Brian. I want to thank Brian. That was an awesome talk. A lot of details, a lot of good examples. Do people have questions? There was one quick question, I think, from Ralph. Is PITcleanr and Pithy, are they free? And Kevin replied that PITcleanr is free, and he thinks that Pithy is as well. Is that true, Brian? Are these resources you shared all available?
Yeah, free as both in beer and in speech, or whatever that means. But yeah, I mean, there's nothing with Pithy. There's absolutely nothing to install. It's basically there. You just load up the URL, and it'll just download right there. And the project itself is certainly open source. It's not going to be restricted to anything. I mean, it's, not going to have huge demand outside of the Columbia Basin, but you never know.
Okay. Good question, Ralph. Any other questions out there for Brian? You can turn your camera on and speak, or you could type it into the chat. Anybody out there? Any, I heard Brian say he's working towards getting a lot of the stuff into, oh, go ahead, Graham.
Yeah.
Hey.
Just to say that's really awesome. I guess I was going to ask, is that that's built in R Shiny? Is that correct?
No.
No. Okay.
This is all HTML and JavaScript. The R Shiny is kind of is interesting, and it's I've done a lot of work with R Shiny, creating a lot of tools that work with PTAG data. In this case, the one thing, and it's possible to do with Shiny, but Shiny in the model of Shiny, you maintain the data on the server, and so visualizations that rely on something happening in the browser, all the data has to be downloaded and then uploaded again. So I wanted to work with something that's starting with a model of all the data, all the processing and all the data is happening on your browser. Mostly because some of these PTAG files can be, starting out 100 megabytes in size, and so how do you, trying to pass data back and forth at that scale with in the R Shiny model is a little bit cumbersome. It really slows things down, and in particular, all the mapping that I do is using the Leaflet package, the JavaScript package for mapping. You can use Leaflet within Shiny too, but what happens there is that when you do just display something on a map, and if it's a lot of data, that's got to be downloaded back down to your browser again to display. And so it's an interesting balance with Shiny being able to maintain, okay, where the data is, how do I, get things to happen. That being said, I mean, it is possible to create a Shiny app, I believe, with PITcleanr, for example, and be able to, drag and drop data into there, have it do something, and then eventually, use the same PITcleanr functionality. So, I mean, there's a lot of capabilities of mixing both models or mixing both worlds. And there's lots of new technologies out there for making use of R within a browser. And I want to explore that too.
Awesome. Yeah, I was gonna ask how are you making Shiny run so fast? But that answers the question. Cheers.
Thanks, Graham. Brian, maybe stop sharing your screen just because we're seeing the screen on the screen into infinity and beyond. There we go. Unless you want to share a slide or something. But what other questions do we have out there for Brian or Kevin? Kevin's still around. I think we could fairly say we're in the office hours moment here. There's Kevin. I guess what I will do in the moment of sharing, I'll share the slide just as a reminder as people are starting to slip away of what's coming up next week. We have several speakers from Columbia Basin Research at UW. If you're familiar with DART, we call it, Data Access in Real Time, and other tools that they have going on up there at CBR, come next week, same time, same place. Any questions? Any questions? Oh, I see. Megan? Go ahead, Megan. You can ask.
Yes.
There you
Hello.
go. Welcome. Thank you.
You guys can hear me, I hope.
Yes.
This is a question, I guess more for Kevin, but really either of you. But it's kind of building off of what was talking about in the chat of having this small scale. So I'm in Southern Oregon, so we're outside of the Columbia Basin region. But yeah, I kind of live in this small scale 5 antenna arrays with a number of different antennas at each of them. So I'm sort of in the spot of probably having, if I'm using PITcleanr, building that configuration file, and just also this program's been running for a while, but I'm sort of new to it, taking it over, and we don't have a really clear database, and so I'm trying to only have to do this once of building things in a way that is stored nicely and then can be pulled into these other things to be cleaned and analyzed. And I was just wondering, I guess, more sort of in the resources side of it, given the nature of this workshop series, of like where to start on these sort of adventures of, building these databases to then, pull into PITcleanr and then, building these configuration files or doing something else.
That's a great question. I think the discussion around like the database to house all of your data is a good one. And I completely understand the motivation around, I want to do this once and do it well and not have to redo it every year or two when I find out what I forgot about. I mean, I don't know. So I've worked with some small projects where the data was not on PTAGIS, but it was not housed in a database. It was, running for a few years, and basically it was, here's a whole bunch of, raw files we downloaded from the readers, like .logs or .text files, right? And all right, I wrote some tools in PITcleanr. You could read those in, and like it puts it all into a consistent format across a few different sites. And then building a configuration file for my own purposes that's fairly simple. It was, it was within one river. It was, I don't know, some handful of sites, right? But that's a little different than actually housing all of that data in a database. And I don't know that I'm the right person to talk to about that. I mean, I guess it depends on how much data you're talking about in terms of how much time and effort you want to invest in that and doing it well. I do know I gave a very similar talk earlier this week, actually, to the Klamath Basin Fish Collaborative. I think they're building a very similar database to PTAGIS to house their data, like using a lot of the same tools and kind of mirroring that structure. But so output can sort of play well with PTAGIS, but not it's obviously not housed within PTAGIS. Again, I don't know depending on how big your project is, if that's worth pursuing or
It's
not.
been
But I
running
mean,
for a long time. That's sort of, it's a few sites, but since like 2007, 2008. So
oh,
it's a
okay,
lot of data. And
yeah,
it's in various iterations of whoever was in my seat here. Yeah, there is sort of an access database and some Excel, but it's sort of in iterations through the years. So trying to get it all in one spot is my challenge right now.
that is a very worthy challenge. Like I really appreciate that kind of work, and I think it's worth doing, and it's worth doing well. But yeah.
Okay, but thank you and for the Klamath tip. I know some of those folks, so I will see what they're up to. Thank
Nice.
you.
Yeah, Megan.
And I think
Another,
oh, go ahead, Mari, and then we're going to jump
Yeah.
to Ralph's question.
well, I mean,
sorry.
another, thing about that is you might, the people at PTAGIS, have, the decades of experience in starting small and building up in terms of, the way they approach that. I mean, there's got to be, a good model there, in terms of starting up a new site for maintaining all that kind of data. And I just asked Kevin, what's WDFW doing? Anything coordinated effort about all the other work going on outside of Columbia Basin? I mean, the stuff in, for example, in the the dam that was just taken out. What the on the peninsula? What am I thinking of?
Elwa.
Yeah, the Elwha, but also just around Puget Sound. I mean, there's a lot of. I just don't know if there's any coordinated effort to sort of start thinking about that in terms of maintaining that PTAG data in a coordinated
Well,
way.
that is the perfect segue for a plug for staying for the week 5 of the webinar series, which is Beyond PTAGIS, more on applying R and other regional PTAG systems. We've invited the folks from Salish Sea and I think Klamath and various other emerging PTAG or established PTAG systems outside the Columbia to come, and it'll be more short talks, but basically like an introduction. We were calling it informally friends you didn't know you needed to know. So that's the last week of the series. So that's a good remark, Brian. And I'm gonna we'll save that so that's a plug for that. So please come to the last week. And I think Mari was trying to jump in about Klamath. I think Klamath is one of those talks. Mari, did you want to add anything else? And then Ralph Lampman has a question. So I guess we're not out of time. I have a feeling like we're running out of time. Sorry. I'm rushing y'all.
Yeah, I was just going to say that PTAGIS is housed within PSMFC. That's where the program is operated and the servers. Within PSMFC, we are working with KBFC to develop a PTAG database that is functional alongside. So like we don't want to develop a new system that maybe then can't be used with these common tools like PITcleanr. So Megan, definitely reach out and we can have a chat about what your needs are down in Southern Oregon. And where you can possibly just link in. And I know there are discussions up in the Puget Sound area to developing a functionally able to talk to or alongside the PTAGIS data. So it is by funding restricted to the Columbia River Basin.
Awesome, thank you.
Excellent. Okay, Ralph, you're up.
Yeah, thanks. I think my questions stem from those comments. I work with lamprey, Pacific lamprey, which don't necessarily home, so they go to, any fish in the Columbia could end up in California or Alaska or even Japan. So just curious about, if there's a good way to find that other PTAG data. If there's easy contacts. It sounds like on May 22nd, we will get into that more, but if there's kind of a quick answer to that question, just wanted to ask.
I can tell you my quick answer, Ralph, which is that it's really hard. There's not a great way. I mean, even just locally, as Brian mentioned, I've been certainly involved in some discussions just within Puget Sound and the Salish Sea for sharing pit tag information. But when you have different groups operating different sites and collecting that data a little differently, like without any kind of overarching system like PTAGIS and some data sharing agreements, it can be really hard to certainly to house all of that data in the same spot. I know like some of the discussions around Salish Sea, which we'll probably hear more about in a couple of weeks, are just around, hey, can we at least share, if I put out some tags, did you find any of mine? Right, like kind of just being able to upload a tag list and knowing where they might have shown up, but it's not straightforward. I'd love to see that broaden out, but I mean, for better or for worse, I feel like that's one of the wonderful things about working with PTAGIS in the Columbia Basin is you want to put in a pit tag site, you generally are required to upload your data to PTAGIS. And that sort of data sharing agreements makes it super powerful because, as you pointed out, like you put out some tags, but you get detections all over the place from other people who are running sites that may or may not be related to your project at all. And that's really useful. It's one of the big benefits of pit tag kind of data, right? Those tags last forever. You get detections all for years, but you need to know if they're not within PTAGIS, you need to know where they might be and just who to contact. And right now, it seems like informal contacts of people who might be running some site somewhere, the best way forward. But I'm hoping that.
Well, I think I recall a presentation from I think it's still an ad hoc work group, and Salish Sea was the part of the title. I am drawing a blank on the name. They actually presented their tool, and they were happy to run code to see if they had detected them. If you sent them something, they would run it. And I believe that those folks are part of the May 22nd group, and I apologize if they're on. I assume they're not with us today, or they would be speaking up. But Ralph, if they're not here on May 22nd, I will track them down. I know Meg Detloff would know that, and I'm not Meg, so I will figure it out. But I do remember sitting in on a webinar with them, and they had it's a prototype system, but it was functional. And that you could send them codes. I don't think you could interact with it like PTAGIS, right? It wasn't as quite that far along, but they were very collaborative sounding people, and that was exactly the scenario they were thinking about. Ralph was animals like lampreys and also salmon stray, of course, and whatnot, and tag other things. So it's the beauty of these tags that they don't have batteries that run out, and you can pick them up over long periods of time. Very cool. Good question, Ralph. We're working on it. It's part of collaborating. Anyone else with a question? I really liked Ben Staten's question last time about workarounds. Someone had asked him, I think it was regarding specifically about the desktop version of Git, or forgive me, Ben, if you're out there. I don't know if people, that's a very useful thing to share with others, that you got stuck in some place and you had a workaround that you shared. And I know you guys covered a few of those sorts of things, but if anyone online had something that popped in their mind and thought, I have a solution for that, feel free to jump in here. This part of the office hours theme here is anyone can share their questions, also their comments. Perhaps we're just getting close to lunchtime, which happens. Right. Well, I think we have filled the couple hours very well. As always, there's a ton of information, and if you missed part of it or want to just go back and see the step-by-step, you can get a recording at pnamp.org, or rather our PNAMP's YouTube channel. And that will be posted next week. Give us a little time to process that, and we'll get that up there. And you'll see a reminder from Amy Poles early next week about the week 4 with our friends from Columbia Basin Research, and then week 5 to follow. So thank you very much to Kevin and Brian for putting together those awesome presentations, and for all of you for being here. Have a great rest of your day.